I am Shoma Bandopadhyay, Assistant Professor of Computer Science and Engineering Department of MCKV Institute of Engineering. Today, I will discuss about the Mergesort algorithm. Now, first I shall discuss how it works. A Mergesort works as follows. It first divides the unsorted list into two sublists. Then it recursively divides each sublist again into halves until each sublist contains one element. A list of one element is considered sorted. Repeatedly merge sublist to produce new sorted sublists until there is only one list remaining. This will be the sorted list. The time complexity of Mergesort algorithm will be order n log n, and it will be in all the cases, for average case, for best case, and for worst case. Now, before going to discuss the rigorous algorithm of Mergesort, let me discuss how Mergesort will work. Now, consider I am taking an array 20, 60, 50, 40, 10, 90, 80, and 30. That means these numbers are the content of my array. So these are the 8 elements which are the content of this array. So let us suppose we are having the particular array where the lower bound is 0 and the upper bound is 7. That means lower bound is the index of this array, this index, and the upper bound is this index. So this index is 0 and this index is 7. Thus the array is initially unsorted. Now I shall split this array logically into some subarrays until and unless I reach to one element per array. I am dividing this array into sublist. So in this array there was 8 elements. So now I have divided into two subarray. Each contains 4 elements. Then these two array again will be divided into two halves and each will contain 2 elements. After that, these 4 arrays will be divided into 2 parts and each will contain 1 element. That means up to this we have to divide the subarrays, and now we reach to the 1 element per array in this condition. Now I have divided the array such that each and every array is consisting of only one element. So whenever there is a single element in one array, that means it is sorted, as there is no other numbers with which these particular numbers can be compared. So this array is sorted. Why? This array cannot be compared with other numbers. Now I shall merge these two arrays into a sorted array. Now when I will merge these two, this become a sorted array. 2060 after merging becomes 2060, this sorted array. Similarly, 5040 after merging, it will become 4050. This is a sorted array. Similarly, 1090 after merging, it will be 1090. This is a sorted array. Similarly, 8030 after sorting, that means sorted array will be 3080. This process will be continued. How? Then 2060, then 4050 again will going to be merged to get a larger sorted array. So the larger sorted array becomes 20, 40, 50, 60. Similarly, 10, 90, 30, 80 will be sorted in this way. and we will get 10, 30, 80, 90. Now they will again merge to get another larger sorted array, and that is the final sorted array. So the content of the final sorted array will be 10, 20, 30, 40, 50, 60, 80, 90. That is the basic concept of merge sort. That is why the name merge comes. As we are splitting the array into two halves, we can say that we are dividing the array into two halves. So this follows the divide and conquer rule. After dividing, we again merge. So this is called the divide and conquer rule. Now I shall discuss the merge sort algorithm. So this is my merge sort algorithm. Okay. So here there is lower bound, upper bound, this is the array. Then meet has been calculated. Meet is basically lower bound plus upper bound by 2. So if lower bound less than upper bound, that is until we reach to single element per array condition, the lower bound will be lesser than upper bound until we will reach to single element per array condition. But when it is a single element, then lower bound becomes equal to upper bound. How? I will show that. So first we will calculate the mid value. Now what was the lower bound? The value of lower bound was 0 and value of upper bound is 7. So the mid value is 0 plus 7. So the mid value becomes 3.5. If the mid value is 3.5, that means the integer of mid is 3. So now the mid value is 3. So when the first I am considering the first array, I will be taking the lower bound to mid, that is from 0 to 3. And for the second array, I will be taking the mid ranging from the value mid plus 1 to upper bound. Now I am going to use the merge sort function and call the function recursively. So if I recursively call the function, and if I think of about the left hand side array, then after dividing it into two parts, the lower bound will be 0 and upper bound will be 3. Again it will be divided into two parts. Thus when it becomes a single array, then only the lower bound equals to single element of the array, then only it becomes lower bound equals to upper bound. So here merge sort, then A array, lower bound, mid. Here merge sort, A array, mid plus 1 to upper bound. Now the array will go on splitting until the lower bound less than upper bound, this condition fails. So when this condition will fail, when lower bound equals to upper bound, this condition will fail. And when the lower bound equals to upper bound, when the array will contains only one element. So when the lower bound is less than upper bound, then the splitting will take place. Now I shall go for merging. So the array, lower bound and upper bound, this is the merge condition. So it is not mandatory that the parameter we are passing and the formal arguments will be same. So here, though I have used same, but it is not mandatory that the parameter we are passing and the formal argument should be same. Now, this is my merge algorithm. Here, in the previous cases, the merge has been called, and this is my merge algorithm. Now start with start equals to the lower bound. Meet equal to lower bound plus upper bound by 2. k equal to mid plus 1 and L equal to lower bound. I know that lower bound plus upper bound is the mid value. Lower bound to mid and mid plus upper, mid 1 plus mid 1 to lower bound to mid and mid plus 1 to upper bound are the two subarrays. I need not to pass mid here. In this case, no need to pass mid here because the mid will be calculated in this place. So mid has been calculated in this place. So no need to pass mid here. Now recursively sorted by Mergesort. Showing the above picture, we can easily understand that we are recursively splitting this and after then recursively merge. So this is my sorted array and they will get merged using the merge algorithm and I shall get the final. This is the final sorted array. These are the sorted subarrays and I will get the final sorted array using the merge algorithm. So basically in our algorithm, start is keeping the trace of lower bound. Mid is mid place value, which is lower bound plus upper bound by 2. K is the index of second sublist. So K will be increased up to upper bound. After merging these two sorted array, I will be keeping the data into a temporary array B. So in temporary array B, the data will be stored after sorting. After merging, the B array content will be dumped into A array. That B array subscript is L and starting of that is LB. Okay, so when LB less than equal to mid and K less than equal to UB, this condition starts. So when this will be the condition for the first sub array, will be starting with LB and it can reach up to mid. First subarray will start from LB, it can reach up to mid. For the second sub array, it will be starting with K. K is our mid plus 1 value and it can be reached up to upper bound. Now what will happen if ALB greater than equal ALB greater than equal to AK? Here, if ALB greater than equal to AK, that means the first subarray has higher data than the second. Then the data of the second content will be dumped into the B array because it is having less value. Suppose in my condition, in this case, assume that 50 and 40. So here 50 is greater than 40, but 40 should come in the array first. 40 should come in the array first when it will be sorted. So when the condition 50 and 40 arises, then what will happen? This ALB is greater than equal to AK. So AK will be stored in B array. So B array will having the data AK content and K will be increased. Otherwise what happened? B array will having the data of ALB. Suppose the condition is 2060. That means 20 is lesser, 60 is greater. So what will happen? In this case, the ALB content will be the content of the B array and LB will be increased. So the content of ALB will be stored in B array and LB will be increased. So in both the cases, AL will be increased because we need to increase the index of the B array. Remember that AL is the index of the B array. So whether we can store from the first array, first subarray, or we may store the data from the second subarray, as we are storing it to the temporary array, the index of the temporary array will definitely be increased. So if in both the cases AL will be increased because we need to increase the index of the B array. If B array gets some content, its subscript is bound to be increased. Okay, so now in this way this while loop will work. It may happen that in first subarray, all the data have got copied here. And the second subarray, some pending data are there. Or it may happen from second subarray, all the data have been copied. But from the first subarray, there are some pending data. So here see, in this case, from this is one subarray, this is another subarray. So when all the things have been copied, that means if the condition of the pointer is here, that means from first subarray all the data have been copied, but from second subarray two data remains. So then the two data will be dumped directly here because this data is already sorted, so no need to compare. Similarly, the case may happen instead of here if 50-60 is there and 80-90 is here. That means this array is sorted and this array also itself is sorted. But 50-60 should come earlier after then 80-60. That means the second array has not been exhausted. Sorry, after secondary, after exhausting of secondary, the element of the first array 80-90 will come. So initially 20-40 10-30, then if 50-60 is here, then 50-60 will come and the second array will be exhausted, and the remaining element of the or pending element of the first subarray will be copied. So here the idea is that it may happen that in first sorted subarray, all the data have been copied in the B array. Remember that these two are already sorted array, and the second subarray has some pending data. Or it may happen from second subarray, all the data have been copied to the temporary array B, and array and the first array have some pending data. So they are to be copied in the target B array without checking because the other one has already been exhausted. So now the case is if LB greater than meet, that is if first sorted array has been exhausted. If LB greater than meet, that is the condition when first sorted array has been exhausted, then the second array content will be dumped onto this B array. When the second array content has been dumped to the B array, then A will be increased by 1 and L also be increased by 1. L is the index of the temporary array or B array. So if this is not the case, then L be less than equal to meet. So in this case, what will happen? This is if this is the case, if K less than equal to UB, this condition will occur. While K less than equal to UB, the content of AK will be stored to BL, L will be incremented by 1 and K will be incremented by 1. Otherwise, if the second sorted array is exhausted, then the pending content of the first sorted array will be dumped into the A array. Sorry, will be the first sorted array will be dumped into the temporary array. Temporary array is not A array, it is B array. So the content of ALB will be stored into the B array and LB will be increased by 1. Similarly, L also will be increased by 1. So after that, the data content of B array will be dumped to A array. In this way, the merging is done. So when merging is done, we can trace the algorithm, that the merge sort algorithm. Consider the particular instance how this is getting merged. So which particular instance we will understand. Suppose this subarray contains 4 elements and this subarray also contains 4 elements. That means we are having 4 data in the first array and 4 data in the second array. They will be merged into the sorted array. Start equal to lower bound. We have started with this start equal to lower bound. Here the lower bound will be passed as 0 and upper bound will be passed as 7. And we know the mid value. So mid value is basically lower bound plus upper bound by 2. So the mid value is 0 plus 7 by 2, that is 3. So we are actually taking the integer, though 0 plus 7 becomes 3.5, we are actually taking the integer value. So the value is 3. Now k is mid plus 1 and we are having this L equal to lower bound. So what was our lower bound? Lower bound was 0. So the value of L is 0. Now k is equal to mid plus 1. So the value of k is now 4 because our mid value is 3. So value of mid plus 1 is 4. That means the value of k is now 4. So the second sorted array subscript ranging here is k. K is ranging from mid plus 1 to the upper bound. And the first sub array LB will be ranging from lower bound to mid. So what is the first sub array? 20, 40, 50, 60. So it is from 0 to mid. This is the 3 value is 3. So it is mid plus 1. This value is 4. So it is from mid plus 1 up to the upper bound. Now k is pointing to the location number 4. So k is pointing to the location number 4 means k is pointing to 10. This is 0, 1, 2, 3, 4th location. So k is pointing to the 10. And LB is point to 0th location, that means 20. So now the comparison will be done between 20 and 10. Okay. So if LB less than equal to mid and K less than equal to upper bound. So if the data pointed by LB is greater than the data pointed by K, and this is my target array, the temp array, and later I shall dump all those data to the first array back again. So here BL equal to AK, this condition will occurs. In this case, which is greater? When we compare to these 20 and 10, 20 is greater than 10. That means the first subarray will be greater than this. So the content of the second subarray will be inserted into the B array. Okay, so we will dump it to the B array, and after that dump all those data to A array again. So now BL equal to AK. So 10 will come into the temporary array and K will get increased. So the value K now points to 5. Previously points of K was at 4th position because its value was meet plus 1. So k points to 5. That means here also L will be increased by 1. Why L will be increased by 1? Because L is the index of the temporary array B. After that, it starts point to 30. So now 20 greater than 30. So when the condition is, we will compare the 20 with 30, then 20 is greater than 30. This condition will be checked. So 20 is greater than 30. This condition is false. So I shall be coming to BL equal to LB. That means I shall come to this condition. So the content of ALB will be stored into the temporary array B. That means 20 will comes to the first location of the temporary array. What is the content of the temporary array in 0th location? The content of the 0th location was 10 and 20 comes to the first location of the temporary array. Then LB will be increased by 1. So it becomes 1. What was the value of LB? Value of LB was 0 and it becomes 1. That means it points to 40. So what is the position? 40's position is here. L becomes 1. So L points to 40. Now L equal to L plus 1 and L is 2. Then LB less than equal to mid. Okay. Now it is true right now. So it has not exhausted. It has some pending data. Now 40 greater than 30 is true. So when 40 is compared with this 30, 40 greater than 30, it is true. So 30 will come down into the temporary array. That means it will check condition of this. ALB greater than equal to AK. What is the content of ALB? That is 40. What is the content of AK? AK's content is 30. So 40 greater than 30. It is true. So 30 comes down to the B array. But how? Because the content of AK is stored into the B array. That is the fifth location content. So what was the fifth location content? The 30 was in fifth location content. 0, 1, 2, 3, 4, 5th. So the 30 is the fifth location content. It has been dumped to the temporary array B. Now K is increased by 1 and that becomes 6. It points to 80. Now when K becomes 6, it points to 80. So L is increased by 1. So it is 3. The value of L previously was 2. So now the value of L becomes 3. So when L becomes 3, it points to this location. So now where the L will points? L will points the location 50. Now what will happen? So it is 3 and points to this location. Now 40 greater than 80 is false. So 40 comes down to BL equal to ALB. That means this else part. So this is the else part. And now LB is increased by 1 and it points to 50. That means the value of L is now 4. So value of L is 4 means it will points 50. If it value is 4, it will points 50. 0, 1, 2, 3, 4. So L denotes the index of this array. So when we denotes the point value for L, it points basically this array. Okay. And when we will denote the LB or K, then we will denote the two sub array. So when I am denoting 4, 5, etc., please consider whether the value of it is L or value of it is LB or value of it is K. Otherwise, it will be confusion. Then 50 greater than 80 is false. Now 50 comes down into the temporary array, and thus LB is increased and LB is equal to 3. So when LB is 3 pointing to 60, because the LB points this array and K will point this array, then I will be increased. So it points to the fifth location, and ALB greater than AK. This checking will be done. So ALB greater than AK, 60 greater than 80, this condition is false. After then 60 will come down. So when 60 will come down, that means this condition BL equal to ALB. So the content of the ALB will be the content of BL now. So LB is now increased by again 1 and it becomes 4 points to 10. So when it becomes points to 10, that means it is 4 and points to 10. Now, what will happen? L equal to L plus 1, that is 6. So LB less than equal to mid. This condition LB less than equal to mid. LB less than equal to mid is now false. So it comes out from this while. LB greater than mid. Yes, LB is greater than mid. So I might be having some pending data yet not copied from the second sorted array. LB greater than mid. That is true. So coming to the next part. K less than equal to LB. UB. So we have to check whether K less than equal to UB. So yes, it is true. If it is true, then content of AK will come to BL and L will be incremented by 1. K also will be incremented by 1. So the 80 will be copied, increased the value of K by 1, and also the value of L will be increased by 1. Now 90 will be copied and K also will be increased by 1 and L also will be increased by 1. That means when the copying of 80 and 90 is being done, then the content of the first array has already been exhausted and there are pending data in the second array. Now K less than equal to B is false. So the while loop terminates. Now it is the condition for the dumping logic. Now the value of B is shorted from the, that means the shorted array, the value of B will be dumped into the A array. From start to UB, the content dumped into the A array. Okay, so thus we can say that the array which was unsorted has been sorted, and the previous data which was stored in A array, though we have stored the sublist or sub-sorted array which was sorted in temporary array B, finally we can get the sorted array as the A array, because we have already dumped the content of B array into the A array. So up to this we can conclude the mark sheet here, and you have to practice the program using the algorithm. I have not syntactically written the code, pseudo code. I have only written the for algorithm purpose. So try to implement this. Okay. Thank you.